Okay, welcome to 5.3, the pH scale first video. In this video, I would like to focus on the first science understanding. The pH scale is a logarithmic scale that describes the concentration of hydrogen ion in aqueous solutions, as well as the second one. Solution with pH less than 7 are acidic, solution with pH larger than 7 are basic, and solution with pH equals to 7 are neutral. So here we go. So what do we know? Well, hopefully you have seen this diagram before, the pH scale. The pH stands for potential of proton or hydrogen. Power of hydrogen is another way of saying, perhaps. It really saying that the pH measures how much potential hydrogen is present or hydronium ions present in water, in solution. If the pH value that you get is less than 7, it's going to be an acidic solution. And if the pH value was larger than 7, so 8 to 14, that's going to be basic. And if it was 7, that's going to be neutral. That's just pure water. Now, when I say pure water, you may be thinking that distilled water is pure. Well, in a sense, yes. Maybe when it's freshly distilled, when it was boiled off from some sort of solution, it would have been very, very pure. But over time, if you leave distilled water on the bench, it might get some carbon dioxide dissolved into water. That actually makes the distilled water a bit more acidic. If you remember, carbon dioxide, which is a non-metal oxide, when non-metal oxide dissolves into water, that makes acidic solution, because non-metal oxide is a acidic oxide. So pure water should be pH of 7, but usually gives you a bit less than 7. Okay. All right. Now, strength of electrolyte is what defines how many ions exist in a solution. We are dealing with how many ions of hydrogen, hydronium ion, exist in a solution here. So, well, we need to think about what actually causes a degree of separation or ionization. In this case, we are looking at the word electrolytes. That might be a new term, so I'll go through that too. Electrolytes, which are compounds that dissolves in solution and release ions. Okay, so electrolytes, basically saying it's salt that cause ionic solution. Strong electrolyte, they completely dissociates. Weak electrolytes, they don't completely dissociate, so just partially dissociates. And non-electrolyte, which is just pure water, pH would be 7. Now, with strong electrolyte, if you are dealing with HCl, you would get strong acid. If you are using sodium hydroxide, which is also a strong electrolyte, but will make strong base instead. If you are using ammonia, NH3, if you put that into water, it's a weak electrolyte, therefore you get weak base. And if you had acetic acid, which is a weak acid, which causes weak acid because it's a weak electrolyte. Hope that makes sense. All right, that was it really. So the idea was that the pH scale is from 0 to 14, and less than 7 is acidic, higher than 7 is basic, 7 is neutral. And we're going to talk about logarithmic scale later.